We now solve the following problem: fit a Poisson distribution for the following data and calculate theoretic frequencies. We are given x and f values and we have to fit a Poisson distribution, and along with that we have to calculate the theoretic frequencies. Now, to solve this problem, we have to recollect the Poisson distribution formula. Formula is P of x equal to k e raised to minus lambda raised to k upon k factorial. Now, if you observe that in all these problems, the focus is on this main lambda, which is nothing but the average, which is nothing but the mean. So, our goal or step one to solve such a problem is to find mean. Now, that is lambda. So we now write down all our x and all our f values vertically. Now 0, 1, 2, 3, 4. F is 123, 59, 14, 3, 1. Now our job is to find lambda, and if you observe, if you recollect that whenever x and f are given, the mean lambda is given by summation of xf upon summation of f. Now, so therefore we have x and we have f column. So we now find the xf column. So basically we have to multiply x with f to get xf. So 0 into 123 will be 0. 1 into 59 will be 59. 2 into 14 will be 28. 3 into 3 will be 9. 4 into 1 will be 4. So now we need to know the sum of all these things. We want summation of xf. Summation of xf will be 0 plus 59 plus 28 plus 7 plus 4. This sum will come out to be 100. And summation of f also we want. So the numerator in this case is 100. Summation of f we have to just keep on finding the sum using a calculator, and you will realize that the sum is 200, and this is summation of f. So you divide by 200, you will get lambda as 0.5. So with this, our step 1 of finding lambda is done. Now we proceed to step 2, in which we have to calculate the theoretic frequencies. Now if you observe that over here, there are some frequencies which are mentioned over here. So corresponding to x0, the frequency is 123, x1 the frequency is 59, for x2 frequency is 14, for 3 it is 3, for 4 it is 1. To calculate the theoretic frequencies, these frequencies which are mentioned over here are called observed frequencies. These are the observed frequencies. Now we have to find the theoretic frequencies. Now, to find the theoretic frequencies, we need to use certain formulas. Value for, now we want to find the frequency corresponding to x equal to 0. Frequency corresponding to x equal to 0. The frequency is, formula is n0 equal to e raised to minus lambda into multiplied by summation of f. The theoretic frequency corresponding to x equal to 0 is e raised to minus lambda into summation of f. So this is how you have to by heart it. The formula is to be by heart it. E raised to minus lambda into summation of f. Now e raised to minus lambda, if you observe in the previous question, was we found in the previous step we found it as 0.5. E raised to minus 0.5. Summation of f, if you observe here, was found to be 200. Now the value for e raised to minus 0.5 is given in the question as 0.60. Whatever value is given in the question, you have to take it. If it is something else, you have to take that other value. So it is 0.60 into 200, and this value comes down to, if you multiply, you'll get it as 120. So if you observe, your theoretical frequency 120 corresponding to x equal to 0 is very close to the observed frequency, which is 123. This should always happen. Similarly, if I want the observed theoretic frequency for x equal to 1, after 0, the next value is x equal to 1. If I want the theoretic frequency for x equal to 1, there is a formula. Formula is n of 0 into lambda upon 1. N of 0 into lambda upon 1. So n of 0 is the previous value which I have to take, which is 120, and lambda was found to be 0.5. If you recollect, lambda was 0.5 here. So this, if you multiply, you'll get the answer 60. Again, your theoretic frequency is very close to the observed frequency, which is 59. Similarly, to find n of 2, the formula is n of 1 multiplied by lambda upon 2. N of 1 is 60, the previous value. Lambda is 0.5 upon 2. This value will be 30 upon 2. If you multiply 60 with 0.5, you will get 30. 30 upon 2 is 50. Again, the theoretic frequency is very close to the observed frequency. To find n of 3, the value is n of 2 into lambda upon 3. N of 2 is 15, the value which I took here. Lambda is 0.5 upon 3, which is 7.5. 15 into 0.5 is 7.5 upon 3, which is 2.5. So again, the theoretic frequency 2.5 is very close to what is observed, which is 3. Similarly, n of 4, which is n of 3 into lambda upon 4. So n of 3 is 2.5 into what is lambda is 0.5 into 4. This you multiply and you'll get the answer as 1.25 into 4, and this will come out to be approximately 0.31. Approximately it will come out to be 0.31. So these are the theoretic frequencies. So, and with this the problem is solved. So only thing which you have to know to solve such a problem, we have found all the theoretic frequencies and then solve the problem. To solve such a problem, you need to recollect that the step 1 is to find lambda doing using summation of xf upon summation of f. Step 2, the theoretic frequencies are given by n of 0, whatever is the first value, is nothing but e raised to minus lambda into the summation of f. E raised to minus lambda is there on the question. This value is always there in the question. To find n of 1, we have to do n of 0 multiplied by lambda upon 1. Whatever number is inside appears outside. N of 2 is nothing but n of 1 into lambda upon 2. N of 3 is n of 2 into lambda upon 3. N of 4 is n of 3, the previous value, multiplied by lambda upon the current value. So the formula is pretty simple. It is n of whatever is the current value, say 5 I want, I will use the previous value, which is n of 4, multiplied by lambda upon the current value, whatever I do. Clear? Okay.